So length contraction, what are we actually going to call that? What does it mean? To develop an equation for that, we're going to use the fact that both of us, you and me and the muon, consider that we're travelling at the same velocity. And we can relate those two together. So we've got equation 1 here, which is the proper length, which you measured at 2.1, and the delta t that you measured that was taken for the muon, 7.02, work out the numbers, it works out fine. Then we come across the next equation, which is the muon's frame of reference, and we end up with the length value there divided by the proper time that you observed, and we come up with equation number 2. We can then, I've said here that the moving observer travels with the muon and therefore observes the proper time, which is 2.2 microseconds. The two velocities are identical, so we've got velocity equals equation 1, velocity equals equation 2. We're now going to equate those two equations together, and that's what we've done here, and we end up with this value when you do all the substitution, that the length that you measure, so the length that you measure is equal to the proper length multiplied by our gamma value that we did the other day. And we saw from that value there, that was actually equal to, so gamma is equal to 1 over 1 minus the square, v squared over c squared. And when you put that into here, we're going to come up with a slightly different equation on there. So when we substitute for gamma into that equation, we end up with that situation there where length contraction, the value L, is equal to the proper length multiplied by the square root of 1 minus v squared over c squared. So that bit there turns upside down and becomes just a multiplication for us to work out.